Good morning, students. Welcome to physics lab. Today we are going to discuss the new experiment, that is magnetic field intensity at the center of a circular coil. Here aim of the experiment to determine the magnetic field intensity at the center of a circular coil carrying current by deflection method. Students, apparatus required for this experiment are tangent galvanometer, students, this consisting of the number of turns. In this coil we can see the number of turns and which having the 4 points. You can see here, if you in the circuit connection, if you connect first two, this indicates we are using 2 turns in the coil. If you connect middle two, it indicates we are using 50 turns in the coil. If you connect last two, that indicates we are using 500 turns in the experiment. Students, with this we are having a compass. Here you can see red dot in the compass, that indicates the north pole, and also you can observe the readings in this compass 0 to 90, and also this side also we can see the 0 to 90, and even from right side also we can see the 0 to 90, and here also 0 to 90 degree readings we can see here. Students, we have to mount this compass and this galvanometer like this. We have to mount it, and this tangent galvanometer works based on the principle of tangent law. And one more experiment, that is rheostat, variable rheostat, and other experiment commutator key. Students, see, if you connect this key, this indicates direct and this one is reverse, or you can take this is direct and you can take this one reverse. While explaining the circuit, I will tell one more time. And one more apparatus, that is a multimeter. In this we have to set it for milliammeter. Okay, and this should be in the direct state. See, this we can convert by pressing the select button. If you press that select button, it will convert to AC, and if you press again, it will convert to DC state. And for this experiment, we have to keep it in we have to set it for a DC state. And other 1 ampere battery. Here you can see, here we have to set it for 4.5 volt, and which having the 2 wires, red wire which indicates the positive and black one is the negative. Students, will start the circuit connection. You can see the circuit diagram. Battery positive point that goes to the positive of the ammeter, and negative of the ammeter that goes to the commutator key opposite end that goes to the rheostat lower end, and rheostat upper end that goes to the negative of battery. And here two more points are there. These two connection which goes to the tangent galvanometer. That connection will give now. First we will start from the positive of the battery. Positive of the battery that goes to the students. Now we will give the circuit connection. First point, positive of the battery to positive of ammeter, and negative of this ammeter that goes to the commutator key, and opposite end of that commutator that goes to the lower end of the rheostat. Opposite end of this commutator key that goes to the lower end of the rheostat, and upper end of rheostat that goes to the upper end of rheostat that goes to the negative end of the battery. And two more connections are here. Here we have to connect the this point to the, here we are connecting middle 2 points, this and this one. And other point which goes to the other point of the tangent galvanometer. Now here we have to set it for milliammeter, and this should be in the DC state. Now we have to take the readings. First we have to on this one, and we have to set it for 4.5 volt. Now if you pass the current, before that we have to set the tangent galvanometer. One more point, this tangent galvanometer, this we have to set this one easily by rotating this coil. We can set such that the points of that needle both sides that direct towards the 0 degree. Yes, now it's okay. Both side points that indicating towards the 0 degree. And one more, we have to set that needle perpendicular to the coil. This needle should be perpendicular to the coil. Now we will connect these 2 points, this one, and here we are using middle 2. So number of turns in the coil, that is n is equal to 15. Now we will pass the current. If you pass the current, the deflection, it should be between 30 and 60. If you pass the current, we have to observe the readings in the compass. Here this side we have to take theta 1 and this side theta 2. This is for direct connection. This is for direct connection. If you reverse this one, that readings we have to take theta 3 and theta 4. Here our observed values are like this. This is our tabular column. Here current, that is 65.5 ampere. Magnetometer readings for direct connection, theta 1 and theta 2 are 34, and theta 3, theta 4 are 35, 36. Average of these 4 values 34.75. Here tan theta, that gives them 0.693, and magnetic field intensity, here we are having some observations and formula. B is equal to BH tan theta. Here BH tan theta is the horizontal component of the earth field, that is 0.36 into 10 to the power minus 4, and number of turns used in the coil, that is 50. In this way we have to calculate the next values, and finally we have to get the average of the magnetic field intensity. We have to add all the 5 values to find 4.9 into 10 to the power minus 5, 2.66 into 10 to the power minus 5. These all values we have to add and we have to divide it. We will get the magnetic field intensity at the center of the circular coil. Here these all values we have to add and we have to divide by minus 5. We will get magnetic field intensity B is equal to 0.2902 into 10 to the power minus 4 Tesla. Thank you.